here waiting, and then I remembered I didn't have a lab runoff for this afternoon. So anyway, we'll go from current slide. Okay. Before we get going there are a few kind of major announcements and not such good news, at least from my perspective. You may consider it better news than I do, but I don't consider it very good news. Let's start with this. Remember last Friday I told you I would be in Opelika on the school business. I was on a curriculum review committee for the state, and we reviewed 2 math courses. Okay, others reviewed others. Math 113 got reviewed by somebody else. But anyway, I was gone all day. Left at 6 in the morning, and we actually got back earlier than I had thought. We were back by 3:30, but it still was a 9.5-hour day. And normally my Fridays were supposed to be 4-hour days, so I asked if I could have this Friday off too, and they said yes. So I will not be on the Birmingham campus this Friday either. I kind of wish I were. I have so much work to do, but there's some things we've got to take care of. Because I was out last Friday, I didn't have a chance to get that done, so we need to take care of some things. So anyway, I won't be on campus at all this Friday either. All right. Next week is a bizarre week for me. I think I told you early in the term, probably first day, and some of you probably knew it already, I have a mild form of leukemia. And so periodically I have to have an appointment with my hematologist so he can check all the blood stuff and see if I need another treatment or not. The odds are I probably do. I can't tell that I do or not. It's just whether the white cell counts are too high, which, just judging by the last time, since the last time I've had a treatment, I'm guessing they will be, and that's not a big deal. I have those on Fridays. But anyway, he'll determine that. But he only sees patients on Tuesday mornings, period. I can't schedule the appointment any other time but Tuesday mornings. And they scheduled it for next Tuesday, 1 week from today, at 10:40. That means I have to be there for blood work at 9:40, which means I won't be here for this class. I'm going to meet with my 8:30 class for 30 minutes and leave at 9 to get back to the Kirkland Clinic to be there by 9:40 for my blood work. So, and the appointment's at 10:40. No way I'll be through before 11, I don't think. So I'll be back here before 12. This class will be long over. So there's no way we're going to have class next Tuesday. Then next Thursday, early in the year, or much earlier, months ago, I signed up for a retirement seminar. You're supposed to go to them so you make sure you get everything done you're supposed to do. They assigned, I told them where I wanted to go. They assigned a date. They assigned it for next Thursday, okay, all day long, okay? So I won't be on campus at all next Thursday. So next week, we're not meeting as a class. We are meeting this Thursday, be here Thursday, but next week we're not going to meet as a class at all. So what would, yes?
So like that's Tuesday and Thursday we're not meeting?
Yeah, Tuesday I've got a doctor's appointment, Thursday I've got the retirement seminar in Tuscaloosa, okay? Then, Friday I have a dermatology appointment, but that's in the afternoon, so I will be on the Birmingham campus. This is next Friday, from 8 till whenever I have to leave for the appointment. I asked them to put it in the afternoon. I don't remember what time they said, but if it's after 12:45, I'll be able to stay 8 to 12. If it's 12:30, I'll have to leave just a little early. 12 o'clock, I'll have to leave a little earlier. But anyway, I will be on Birmingham campus next Friday. I won't be this Friday, but I will next Friday. Okay, so what does that mean for the class? Well, I think between today and tomorrow, we will probably finish, certainly going to finish 4.7, hopefully today, and get started on 4.8, and then by Thursday, hopefully we'll finish 4.8, and I'll probably go on and give you your test then, okay? But we can't afford to miss a whole week of class. So what we'll do on Thursday, day after tomorrow, at the end of class, I'll show you what classes to watch. Okay, here's the thing. We can maybe make up classes on a Friday, if you want to do that, or Monday morning or Monday afternoon or Wednesday morning. I have at least an hour and 15 minutes available on Monday morning, Monday afternoon, and Wednesday morning, and Fridays. Do you want to try to make up the class, or do you want to watch it on YouTube videos from what I did last time I taught it? You want to watch it on YouTube? Okay. So next time at the end of class, I'll show you which videos to watch for the next week. Okay, and I'll go on and give you your, whether we finish chapter 4 or not, I'll go on and give you your test, and the videos will finish up. I think we'll finish the chapter by Thursday, but if we don't, you can finish watching it on the video and then do the test, and then watch the next 2 videos. Okay? Sound like a plan? Okay. We'll go with that. Sorry about that. I just can't believe everything's happening on the same week. It's bizarre. All right. Any questions on anything we've done so far? Oh, and by the way, too, here's another thing. This is not any huge concern of yours. I don't know when the summer schedule's coming out. They said we had to have it in by Sunday, like March 1st on Sunday, but now they moved it to Monday, I think. But they still haven't told us what days everything's up in the air what we're doing this summer. So I don't think it'll be ready on the time that they normally say it is. So anyway, any questions, trig or otherwise? This is where we left off last time. We had been doing the inverse tangents of the other, or inverse functions of the other trig functions, this being cosine and tangent. We don't usually mess with cotangent, certainly don't mess with secant and cosecant, okay? So let's do these 2. Now, if you remember how I suggested that we do the inverse sines, hopefully you'll figure out how I want to proceed on this. Find the exact value of arc cosine, which is the same as inverse cosine, of root 2 over 2. How would you begin this? Say again? All right. And I like the way you said that, because a cosine function operates on an angle to give you a number. The inverse cosine operates on the number to give you an angle, so the answer for this question will be an angle. And that's what you're looking for. You want to give it a specific name?
Theta.
Oh, everybody's, or my favorite anyway, is theta. Okay. So that's how I begin anytime I have an inverse trig function. You start by saying, inverse trig function is going to give us an angle. Now, I want to take that equation and rewrite it in another form. What would be the other form? Say again? Square root of 2 over 2 equal cosine theta. Perfect. Way to go. Now you ask yourself the question, what angle theta gives you a cosine of root 2 over 2? Those are ones we know and love. Some of our favorites. Pi fourths, absolutely. So theta, this implies theta would have to equal pi fourths. Now, my question to you, and if you wanted that in degrees, what would that be? 45 degrees. Perfect. Y'all are good. Okay? Now, what if I say, oh, there are other values of theta for which that's true? Would that be a true statement? Yeah. Okay. Aaron? All right. All right. Sorry, y'all are going to hear this every time someone else comes in. And it's taking too much class time, but I did want you to know. We're having class today and Thursday, of course, normal. Okay. Next week for this class is a wash. I have a doctor's appointment on Tuesday. I have a meeting in Tuscaloosa on Thursday. The whole week we're missing. So next class on Thursday, at the end of class, I'll show you, this is what the class decided they wanted to do. I'll show you the YouTube videos that you'll need to watch for the 2 days of class next week. I'll also have, okay, let me start over. Here's recording. Boy, I was giving them the bad news that we do have class today and Thursday. Normal. Everything's normal for this week. Next week is not normal. Okay. I have a doctor's appointment on Tuesday that starts at 10:40, but I have to be there for blood work at 9:40. So that's going to wipe out the first of class. The doctor's appointment will go at least until 11, and I won't be back here until probably earliest will be 11:45. So wipes out the entire class on Tuesday. Then, and I couldn't help it. Well, let's start again. Okay. Nikhil's here, right?
Yes, sir.
All right. Try this one more time. We have class today and Thursday. Okay. Hopefully by then we'll finish chapter 4. Hopefully by then, and definitely by then, I'll give you the second test from chapter 4, 4.5 to 4.8, 4, 5, 6, 7, and 8. Okay. I'll have those ready for you and give them to you Thursday. Whether we finished 4.8 or not. Okay, and here's why. The next week, okay, I have a doctor's appointment on Tuesday that's going to wipe out this class completely because I have to be there for blood work at 9:40, and my doctor's appointment goes until, well, it starts at 10:40, probably will go at least until 11. It'll take me 30 to 45 minutes to drive, closer to 45 minutes to drive back here. So wiping out this class completely on Thursday, on Tuesday. Then on Thursday, I've got a meeting in Tuscaloosa all day long. Why they had to happen in the same week, I don't know. And then on top of that, I have another doctor's appointment that's an annual thing on Friday. But that's Friday afternoon. That shouldn't interfere much with my office hours. I may have to leave a little early to get there, but that's all. Okay, that's a dermatology appointment. I can control that. I can't control my hematology appointment because he only sees patients on Tuesday mornings. That's the only time he sees patients. So I could not schedule it any other time. So they scheduled it. Okay, and then I forgot this one. Well, I told the others, but I forgot this one for y'all that just came in. Last Friday, I had meetings down in Opelika State, whatever they call them, curriculum review meetings that I was required to be at. And so we left at 6 and actually got back earlier than I thought we would. Got back by 3:30, but it still turned out to be a 9.5-hour day. And since I technically only supposed to work 4 hours on Fridays, I've got this Friday off as well. So that covered 2 Fridays worth plus some, but that's okay. So I won't be on the Birmingham campus this Friday. But I will be on the Birmingham campus next Friday, at least until I have to leave for my dermatology appointment. I asked them to put it in the afternoon. I don't remember what time they put it, so I'll find that out. Okay, but at the end of class on Thursday, day after tomorrow, I'll show you the videos that you'll need to watch. The class who got here, were here at the beginning of the class, decided they wanted to watch the videos rather than trying to make up class on Monday morning, Wednesday morning, Monday afternoon, or Friday morning. So I'll show you which videos to watch, and you'll be continuing in chapter 5. Okay? Okay with that? All right. So we had just done example 3A. Any questions on that? Okay. How about this one? Arctangent of 0. How would you begin that? Okay, you're looking for an angle. Do you want to give it the same name or a different name? Okay, we'll call it theta. Now, once you've done that, rewrite the equation. How? 0 equal tangent theta. Oh, I remember now what we were doing before first people started doing that. You might say here, oh, but there's a lot of angles who have a cosine of, the cosine of those angles would be square root of 2 over 2. How do we know which one to write down? Yes, it has to be between 0 and pi, okay? Cosine 0 to pi, that covers the full range. So that's the only angle in 0 to pi, or 0 to 180 degrees, that would work. No, that's not right. I said it wrong. No, that's right. That's 0 to pi. Now, so 0 is equal to tangent theta. What angle theta has a tangent of 0? Oops. 0. Okay. Theta would have to be equal to 0. And that could be 0 radians or 0 degrees, either one, I don't care. 0, and that's the only angle that would be the case. Yeah, there's plenty of other angles that have a tangent of 0, but because the range of the inverse tangent or the domain of tangent that's 1 to 1 is between minus pi halves and pi halves. And that's the only place where that would be equal to 0. All right, good deal. How about this one? Inverse tangent of -1. Where would you begin? And what do you want to call it? Theta again. Good deal. What does that imply? How do you rewrite that equation? Second. -1 is equal to tangent of theta. Okay. Now, what angle theta has a tangent of -1? Anybody? Angle theta has a tangent of -1. Yes. Are there any that have a tangent of -1? Say again? Did you say pi? Okay. Number 1, tangent is 1 to 1 only between -pi halves and pi halves. Pi is out here outside the domain of tangent, outside the range of inverse tangent.
3/4 pi?
Okay. 3/4 pi, in answer to this question, that's absolutely true. 3/4 pi. But remember what the domain of tangent that's 1 to 1? Only between minus pi halves and pi halves. 3/4 pi is out here. So therefore the range of inverse tangent, that would be outside of the range. So where would be inside of the range? What is the other angle? Another angle who is also 3/4 pi. No, okay, I didn't quite say that right. Another angle whose inverse tangent is -1. The tangent of which is -1. Okay. Now for the tangent function, here's what you do. Picture this, okay? You just said it absolutely right. At 3/4 pi, there's 1/4 pi, 2/4 pi, 3/4 pi. That is absolutely right. The inverse tangent is -1. But remember, tangent is positive here, minus here, positive here, and minus here. So the other angle is this one down here. And what is that? Between negative pi halves and pi halves. Negative pi fourths. So this would be theta is equal to negative pi fourths. Because sine of negative pi fourths is -1, cosine of negative pi fourths is +1, and sine of negative pi fourths is -√2/2, cosine of negative pi fourths is positive √2/2, -√2/2 positive √2/2 is minus. That's what it is. Not this one up here. You're absolutely right. 3/4 pi does have a tangent of negative pi fourths. But to fit this, to be in the domain and range of inverse, you have to be down here between minus pi fourths and pi fourths. So that's minus pi fourths. Does that make sense? Yes?
Does the way it rotate affect, like, you go counterclockwise?
Does what?
Does the way you go back in your answer on the answer?
Yeah, because it has to be a one-to-one function, we define the tangent to be 1-to-1 only between minus pi halves and pi halves. Sine is only 1-to-1 between minus pi halves and pi halves. Cosine is between 0 and pi. That's why we had to choose for this one pi fourths here, okay? Because it only, and that goes back to this, okay? Well, this is this is sine. The inverse sine, the answer to this has to be between minus pi halves and pi halves. Has to be, because that's the only place where it's 1-to-1. You start going up here, it's no longer a function. Or down here, it's no longer a function. So you have to stay between these two. Cosine stays between minus pi, 0 and pi. Okay? And inverse tangent stays between minus pi halves and pi halves. One difference here, you can be negative pi halves and pi halves for inverse sine. You can't be for inverse tangent, because this is a horizontal asymptote. Yeah. The domain and range are important here. Okay. So that's why, even though the the tangent of 3/4 pi, you're absolutely right, was -1, it's outside here. Oh, I'm sorry, outside here. See, 3/4 pi would be up here. So you have to get the same value, which would be 1 down here. -1 right there. At negative pi fourths. Make sense? Good deal. Now, that's how I do it, and I think it makes sense that way, of course, or I wouldn't do it that way, probably. But they do it this way, which sort of drives me nuts. They say, because this is the answer, this is the answer. Okay? I go, what? They say because this, and it's the same thing I'm saying, but they just plug in the answer. To me, you plug in the unknown here. That's the unknown, theta. Because cosine theta is this, find the angle theta, well that is by force. And it's in the range, or domain, depending on, it's in the domain of cosine in the range of inverse cosine between 0 and pi. Okay? So that's the one we choose. So the way they express it, it says, we know the answer because that's the answer, that's the answer. You know, and I like to do it the way David was doing it. Just choose an angle, that's your unknown. Now, which angle makes that work? And y'all did it well. And again, they do the same thing here. Because that's the answer, this is the answer. Okay. Duh. Okay, I like the way y'all did it. Choose a theta, and then look for the theta whose tangent is 0. And that happens to be 0. So they're absolutely correct. And 0 is between minus pi halves and pi halves. Notice here, parentheses, because you can't be either negative pi halves or pi halves, so you be sure you put it in parentheses there. Whereas for the cosine one, these are brackets here because you could be at the end points. Not a big deal, but a little deal. And then the C, again, because this is the answer, this is the answer. It just doesn't make. Find the angle theta, whose tangent is minus 1. Well, that angle happens to be minus pi fourths. Because pi fourths, minus pi fourths, lands in between minus pi halves and pi halves. 3/4 pi makes this true, but it isn't in your domain or range there. Okay, so this is the one we choose. All right, does that make sense? And as in every example they give, there's also a checkpoint. Please do the checkpoints and see what you can get. And here's Amari. Now, sorry folks, but I need to make sure everybody realizes this. Okay, I'll start with the beginning. I'm not going to be on Birmingham campus Friday morning, 8 to 12. I had a long Friday last Friday at meetings down in Opelika, so they gave me next Friday off too. So, won't be on Birmingham campus next Friday. I will be here the rest of this week. Now, next week for this class is a total wash, and I'm sorry about that. I told the class early in the term I have a mild form of leukemia, so I have to see my hematologist periodically, usually twice a year, something like that. This visit happens to come up next Tuesday, okay, a week from today. He only sees patients on Tuesday morning, so I couldn't avoid a Tuesday morning appointment. That's the only time he sees patients. And it happens to come right at a time, wipes out the whole class. So we won't be meeting next Tuesday because of my doctor's appointment. I will be back later in the day. I will be here before, I'll be here from 8 until 9, and I have to leave to go to the appointment at 9. I'll probably be back before noon, hopefully be back before noon. I'll meet my afternoon class, but I won't be able to meet this class. Now, if that wasn't bad enough, Thursday I've got a meeting in Tuscaloosa, all-day meeting. So Thursday's wiped out too. So what we're doing on Tuesday, right at the end, Thursday, day after tomorrow, right at the end of class, I'll take you to the YouTube videos and tell you which ones to watch for next week's material. Okay, they're out there from a previous term, last term, and I'll show you which ones to watch. Now, also, I will give you next Thursday, day after tomorrow, I'll give you the second test, which covers the last half of Chapter 4, 4.5 to 4.8. Whether we finish 4.8 or not, you'll have the test so you can work on that next week as well. Okay. And anything we don't get covered, you'll watch on the video. Okay. And we just finished Example 3, ready to move to Example 4. Any questions? Now, the following Friday, after that Thursday when I'm in Tuscaloosa, I'll be back on the Birmingham campus. 8 until I have to leave. I have a dermatology appointment in the afternoon on Friday, I don't remember what time. If it's late enough, I'll be there 8 to 12, but I can't be there later. Okay, so there's example 3. They are skipping example, wait a minute. Okay. They're skipping example 4, so let's go. In fact, that's a good place to do example 4. Let's do example 4 right here. Then we'll come back and do this slide. This time, pull out your calculators. These are not the angles we know and love. These are other angles, so here you'll have to use a calculator. And for the first one, we're looking for arctangent of negative 8.45. Oh, yeah, sure. Oh, pencil. I'm sorry. I thought you said stapler. Okay. Is the eraser good on that? Okay. All right. Got a calculator? Okay, number 1, before you even plug it in, do you think that there even is an angle whose tangent is negative 8.45? Sure, because tangent goes from minus infinity to positive infinity. So yeah, it'll include negative 8.45. Okay? Where do you think that angle will be? Between negative pi halves and 0, because that's where tangent is negative, down here. Positive up there. But it has to be between minus pi halves and pi halves. So it'll be on the left-hand side, between minus pi halves and 0. So that's the angle you're looking for. Now, before you do this, there's no way to tell, looking at this, whether they want the answer in radians or degrees. So be sure you know what mode your calculator's in before you enter this. If you're in degree mode, it's going to give you degrees. It won't necessarily say it. Maybe somewhere you'll see a D or a DEG or something, but don't give me the answer in radians if it's really in degrees, or in degrees if it's really in radians. Now, the next slide we're going to do is the one at the top. By definition, the values of inverse trigonometric functions are always in radians. So the way this book treats it, they're always looking for a radian measurement. So before you do this, be sure you get in radian mode. Then do this. Now, do any of you find on your calculator a button that says arctangent? I'm guessing no. So what do you use? The other way to express this, which is inverse tangent. That's the button you use. Because now some of the older calculators used to have arctangent on it. And the inverse tangent is usually a shift of the tangent function, or some other key with the tangent function. Do you find it? And depending on your calculator, some of the old scientific calculators, you had to enter this first and then hit the button. Most of the newer calculators, you hit that and then press that. But be in radian mode, because this book always is assuming you're in radians, unless it tells you something else. Anyone got an answer yet? Okay. Negative 1.4. And that would be radians, not degrees, so don't put a degree sign by it. If you put a degree sign by it, that means you're in degree mode. You're not. You're in radian mode. Now, negative 1.4, is that between negative pi halves and pi halves? And 0? Yeah, because negative pi halves is approximately negative 1.5 something. Okay? So yeah, this is inside that, but not inside by much. They actually give it as negative 1.453. I would stop at 3. Not that I like 4 digits, but the next two digits are 0, so that's close enough for me. Okay? All right, the B one here is inverse sine of 0.2447. Okay? Be sure you're in radian mode. What kind of answer do you come with? First, do you think there is going to be an angle whose sine is this? Yeah, sines are always between -1 and 1. That's certainly between that. And this is going to be on the positive side of that, so this will be between 0 and pi halves. Remember, it always has to be within that. Okay, what angle do you get? Should. Second? 0.24 what? 7. Okay. In the book, they put a few more digits to 1. I would stop there because the next one's 0. It doesn't matter. That's close enough. Okay. Now, a little timeout here. Okay? I'm going to go back a few slides, but hold your thought. Okay? Let's take a look at something. Look at this line right here. That's awfully close to the identity function, y is equal to x. That's almost a 45-degree line there. It's a curve, but it's really close to a straight line. That means for sine functions and inverse sine functions, anytime the angle is pretty small, you're pretty close to being a 1-to-1. And what did your answer there? The input was 2445. Your output was 0.247. Really close to each other. And that's why, because that's close to a straight line. Look at the tangent. Also, really close angles here. This is almost a straight line. Of course, when you're out at -8, you're way out here. Okay? That's not going to be anywhere close to this one. Okay? But any small angles, you're going to be relatively close, both on inverse sines and inverse tangents. Cosines out the lunch. Okay, don't worry about that. They're not going to be anywhere close. But I just wanted to point that out to you. That notice how close these are to each other. And that's because you got the very small angles there. Sines, inverse sines and sines are very, in radian mode. In degree mode, they're nowhere close. In radian mode, they are. All right, too much of that. How about this one? Arc cosine of 2. What does that give you? Oh my goodness. How did you get that? What's that? Oh, you didn't do inverse. Okay, do inverse. What do you get? Error! Why do you get an error? Because cosines are always between -1 and 1. This one's 2. Outside, can't do it. It's outside of the domain of inverse cosine. It's outside the range of cosine. Can't do it. Does not exist. Oops, C and E. Okay. I don't know where the O came from. Does not exist. The arc cosine cannot get. Okay? The calculator should display an error message because the domain of inverse cosine function is between -1 and 1. Can't be a 2. Ever. Ever. There is a checkpoint there. Please do checkpoint as soon as you can outside class. Okay? Now, go back to this. All right, to erase. Everybody got it? Okay? By definition, the values of inverse trigonometric functions are always in radians. At least in this book, that's what they're always going to be. So don't look for them to be in degrees. Okay. Now, next topic, compositions of functions. Okay. Hey, we did this back in pre-calculus algebra, right? Yeah, we can do it with trig too. We know that for all x's in the domains of f and f inverse, an inverse function have these following properties. F of f inverse is going to be x, and f inverse of x, f is going to be x. Why? Because the inverse function undoes the function. So whatever you do with f inverse on x, f undoes that and gets you back to x again. And whatever you do with x on f, inverse function takes you back to x again. So that better be what they come out to be. So we can take the same property and take it to the inverse properties of trigonometric functions. Now remember, what's important are your domains and ranges. Okay? Because the inverse trig functions are only defined for very specific domains and ranges. Very specific. Okay? Because trig functions are not one-to-one except in very specific domains and ranges. So, if your x is between -1 and 1, when I look at that, I know you're talking about either sines or cosines. Okay? This has to be talking about sines. And between negative pi halves and pi halves to y, that means it has to be talking about sines, because that's the ranges of an inverse sine. So these are domains of either inverse sine or inverse cosine. This is the range for inverse sine, so you're dealing with inverse sine. If the x's are in here and the y's are in there, then the sine of the arc sine, just like f of f inverse, sine of arc sine is going to be x, if these are within those ranges. And the arc sine of sine y, if y is the angle in between minus pi halves and pi halves, the arc sine of sine is going to be y. Has to be, because the inverse functions are that. Now, you might say, well, why didn't they use x here? Well, they already defined x's to be here, y's to be here, so they couldn't change it around. So, for these y's and those x's. Okay? Now, negative 1 to 1, you know it's either sine or cosine, but now if the y's from 0 to pi, that has to be inverse cosine. So if the x's and y's are in between here, the inverse cosine of, the cosine of inverse cosine of x is going to be x, and the inverse cosine of y, these are the angles here, cosine y is going to be y. And if x is any real numbers, why is that? Because the domain of inverse tangent is all real numbers. So if x is any real number and your y's are between minus pi halves and pi halves, not including the endpoints. See, these have the equal signs. This one does not have the equal sign. Because you cannot take the tangent of negative pi halves or pi halves as a vertical asymptote. Okay? Then the tangent of inverse tangent of x is going to be x, and the inverse tangent of tangent is going to be y. Whatever is in here will be out there, if you're within those domains and ranges. Make sense? All right. Just noticing we're only. Okay. All right. Now, these inverse properties do not apply for arbitrary values of x's and y. You can't just pick any x and y and make that work. For instance, why won't 3 has pi work? You can certainly take the sine of 3 has pi, no problem there. But when you do the inverse sine, it cannot give you 3 has pi because that's outside the range, okay? So, the sine of 3 has pi is going to be -1. Okay, I should cover this and ask you that. What is the sine of 3 halves pi? Already said it, minus 1. What's the arc sine of minus 1? Say again? No, it can't be, because that is only minus pi halves. That's the same as 3 halves pi. 3 halves pi would be here. There's 1 half pi, 2 halves pi, 3 halves pi. But that's not it. That's also the same as negative pi halves, and sine is only defined for negative pi halves pi. So you have to go back and use a value within your range of arc sine. And the range of arc sine only goes from negative pi halves to pi halves. So 3 halves pi is not in there. So you can't do that. In other words, a property, the arc sine of sine y equal y, only works when y is in this interval. Okay. Sort of hard to say whether it's the domain or a range. It's the domain of sine, but the range of arc sine. So in that interval. Not valid for values of y outside there. So 3 halves pi is outside that. So you can't use this identity here for anything outside. Only for things within that. If it's outside, it's going to give you an answer that's inside. Okay? And it won't be the same as the y. All right. So if possible, let's do this one. The tangent of the arctangent of negative 5. Now, again, I like to think of it this way. The arctangent of negative 5, arctangent is going to be some angle. Let's call it theta. Is there some angle theta? But when you take the tangent of it, you get negative 5. And if there is, and of course there, well, okay. Number one, can you do that? Is it possible? Remember the domain of tangent function?
Yes.
All real numbers. So negative 5 is certainly a real number. And because that's in the domain, what's going to be your answer here? This one will work, and this will be negative 5. That rule works here because that's in your domain. In the interval. Okay. Yes?
So your answer is negative 5.
Answer is negative 5 because you've undone what you did. The inverse tangent of negative 5 gives you some angle theta, and the tangent of that angle theta is negative 5 because you undone it and done it. Okay? So that does fit the bill. How about the second one here? Can you take the sine of 5 pi thirds? You can take the sine of it, yes. Okay, well, let's take the sine first. I like inverse sine. I'll just do that. What is the sine of 5/3 pi? Okay, I'll do it on here. I like to do my little things. Here's 1/3 pi, 2/3 pi, 3/3 pi, of course, 4/3 pi, 5/3 pi, right down here. Okay, there's where you are. Okay, and what's the sine of that? First, what SIGN sign does it have? Fourth quadrant. Okay. The sine is the y value, right? And this will be
So it'll be
negative square root of 3 over 2. Right. Okay. Now, what's the inverse sine of negative square root of 3 over 2? The same little diagram I did out for you. Inverse sine is only good from minus pi halves to pi halves. Say that again? No. this has to give you an angle, right? But I'll tell you what, the angle will not be 5/3 pi. It will not be that. It will be negative pi/3, because the sign, it only goes from minus pi halves to pi halves. And this angle right here that we just mapped out here is in that, but this is the angle, minus pi/3. You see that? The sign of this is that, negative square root of 3/2. But the inverse sign for this value right here is going to be the angle here, not the angle here. It will be this angle, because the inverse sign is only defined for minus pi halves to pi halves. This is out. This one's outside that. So you can't use the same rule you did here. You have to use I want to say a coterminal angle. They're not always coterminal, but this one happens to be. See, this is in the domain of the inverse sign. That one is not. But you can still take the sign of it. You can take the sign of any angle in the world. Okay? But the inverse sign, you can't. It won't give you a value that's outside negative pi halves to pi halves. Does that make sense? Those inverse signs have to be 1-to-1. Sine doesn't have to be 1-to-1. Okay? So you can take the sine of any angle in the world, but then when you go back and take the inverse sine of it, you've got to be between minus pi halves and pi halves. That's the bottom line here. Does that make sense? Okay. How about the next one? Can I erase this? I wrote too much. All right. The cosine of inverse cosine of pi. What you think on that? Anybody? C. Cosine of inverse cosine of pi. Say again? I can't hear you. I still can't hear you. You said?
He said, didn't you already undo it based on the rule?
Okay. Well, that's the question. Okay. What are we talking about here with the inverse sine, inverse cosine? What is the answer for that going to be? This is how you started the other problems, right? That's going to be some angle theta, right? So the question you ask yourself, what angle theta, when you take the cosine of it, will give you pi? So in other words, the cosine of what angle theta is going to be pi. What is cosine always? Between? No. Take a cosine of any angle in the world, and where are you? Between plus or minus 1. Pi is outside that. This is does not exist. There is no, you cannot take, if you try on your calculator and put in the inverse cosine of pi, you'll get an error, right? Okay? Because you can't do it. And here's to me the dead giveaway here. You can take the cosine of a pi, because pi is an angle usually. It doesn't have to be. It can be a number. But you can't take the inverse cosine of pi. It's an inverse cosine of a number, and that number always has to be between plus or minus 1. And that's not. That's outside. That's 3.1415, blah, 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 blah. Way outside, plus or minus 1. Okay. So that was example 5. No, it isn't. Yes, it is. Okay. And the C part says not defined. I put does not exist. They put not defined. Whatever. The other one was negative. Oh, wait. They're going to show these. Let me erase them and show. Okay. I forgot. All right, to erase. Okay, the first one, because negative 5 does lie in the domain of the arctangent function. Arctangent function goes from minus infinity to positive infinity. So that certainly lies there. So therefore the inverse property applies, and the tangent of the arctangent minus 5 is going to be minus 5 because this is in the domain of that. So no problem, then you just write it down. Okay? Inverse property. Okay. Now, the B one, in this case, 5/3 pi is not in the range of the arcsine function. The arcsine function only goes from minus pi halves to pi halves. 5/3 pi is not in there. Okay? However, if you draw the function, 5/3 pi is in there, but it's not in 5/3 pi. This is negative 1/3 pi. Right? Because you're 1/3 pi short of 2 pi, which would be 6/3. So the answer to this one is you can take the sine of 5/3 pi. No problem there. Sine is defined for all real numbers. But the answer you get for this is negative root 3 over 2. And when you do the arcsine of that, the inverse sine of that, that's going to give you something between minus pi halves and pi halves, which is minus pi thirds. Okay. And this works because these are coterminal. There are also some that may not be coterminal, but you'll still do in a very similar way. That sounds wishy-washy, and it kind of is. It's certainly, if it is coterminal, that works. But if it's not coterminal, it may still work. Okay, and they're not going to give you an example like that now. Okay, but well, I'll show you an example of that. Remember, we said 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi. The sign of that is also negative root 3 over 2. Okay, but the angle in between minus pi halves and pi halves, who has that same value, is this one, minus pi thirds. So it doesn't have to be a coterminal angle. It certainly works if it's a coterminal angle, but even if it's not a coterminal angle, the one with that same value is not. You can't even do it that way. You have to think through what angle. So 4/3 pi gives you minus root 3 over 2, but the angle whose arcsine is minus root 3 over 2 is negative pi thirds, because this has between minus pi halves and pi halves. That may have just made it murkier, but it's not only coterminal angles. Certainly coterminal angles work, but it's not only coterminal angles. Okay. And that's minus pi thirds. Okay. And this one, not defined because inverse cosine of pi is not defined because pi is outside minus 1 to 1. Okay. Remember, the domain of the inverse cosine function is minus 1 to 1. The domain of the inverse sine function is minus 1 to 1. The domain of the inverse tangent function, all real numbers. All right. That was example 5. Let's go back and do example 6. Let's do that here. Find the exact value of each expression. The tangent of the what? Arc cosine of 2/3? What in the world would that be? Okay? Now, here, folks, we go back to David's method or he was the one saying it out loud. I hope all of you have that. What does this represent? An angle. What do you want to name it? Theta. Okay. So we have here arc cosine of 2/3 is equal to theta. Rewrite that in another way. Rewrite it in another way. What we have here is, I'm going to write it as inverse cosine because it's easier to write. Inverse cosine of 2/3 is equal to theta. Up. I keep writing zeros instead of thetas. Okay. Or phis instead of thetas or whatever. Rewrite that equation in another way. You were doing it earlier very nicely. As a trig function, not an inverse trig function. Two-thirds equal. Whoa, what? This equation here. Cosine of theta. Very good. Now, draw a picture. Right? Now, I'm going to draw not a unit circle, a 3-unit circle. In other words, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Why? Because your hypotenuse is 3. This is an ugly circle, isn't it? Terrible, terrible, terrible. It's not that funny. Okay. Now, the cosine of theta is equal to 2/3. What does cosine represent? Remember that? A long time ago. Second? What's the definition of cosine? Call another hen. Second? That we call some old hen. This is called another hen. Adjacent over hypotenuse. And the adjacent side is the x-axis. In other words, it's x over r, right? Remember that one? Please say yes. Okay. X over r. Okay. The radius here is 3. The adjacent is 2. So there is your angle theta, right there. Okay. So this is 2 this way, 3 this way. So what is the tangent of that angle theta? Tell me what tangent is. Taking oats away. Opposite over adjacent. Well, the opposite is the y value. Y over x. That should ring a bell too, but it probably doesn't. We need to know what the y is. Is there any way we can get that y? A Pythagorean theorem. Okay, what does that give you? Y is equal to the square root of 9 minus 4, which is the square root of 5. So the tangent of theta, which is what that is equal to opposite, which is square root of 5 over 2. There's your answer. Does that make sense? Pictures are worth thousands of words. Okay? So if you don't want me to be talking forever, draw a picture and get me to shut up. Okay? Yeah, fat chance of that. Okay. You see how that works? Boy, use your pictures. Okay, let's see if the book got it right. Oh, look at that, they did. Okay, good for them. All right. Can I erase this one? You got it? Keep writing as long as you need to. Any questions on it before I erase it? Everybody see it? Yay or nay? Okay, can I erase? Okay, yay, okay. Got some sort of an answer. Okay. All right, let's do the B part. The B part says the cosine of the arc sine of negative 3/5. They put this in bracket, that's okay. Guess where we're going to start on this one? Start at the innermost part. What does this tell you? This is going to be a what? An angle. You want to name it theta again? It seems to be our favorite. So give me another equation that says that same thing. Negative 3/5 equals what? Sine of theta. Exactly. And what is sine, by the way? Opposite over hypotenuse. So the hypotenuse is going to be 5, so this is a 5 circle. Thought it must have said something right. I want a prize. Okay. Hit the jackpot. Okay. So there's a 5 circle. It's an ugly 5 circle. Okay. So the sine of theta is equal to negative 3/5. Well, negative is the y value, so you go down 3. So you're either over here or over here. I can't tell. One of those two angles, right? But I don't know which one, okay? Oh, yes, I do. Because sine is always between, arc sine is always between minus pi halves and pi halves, isn't it? So this must be the angle where I am, right there. This angle right here. That's my angle theta. See how we got that? The arc sine of minus 3/5, that has to be some angle theta. And so the sine of that angle theta has to be minus 3/5. Well, sine, the inverse sine is only between minus pi halves and pi halves. So minus 3 over 5. The radius is 5. This is your minus 3 here. This is your 5 here. So this must be your angle theta. Only choice, right? What's the cosine of that angle? What is cosine? Okay, adjacent over hypotenuse. So here is the adjacent side for that angle right here. This is your adjacent side. Whoops. I kind of cheated a little bit, okay, because I knew what the answer was. How did I know the answer? What kind of triangle is that? Second? It's a right triangle for sure. What are the lengths? It's one of those Pythagorean triangles. What are the lengths? Okay, we know this is 3, this is 5. What would your adjacent side have to be? The square root of 25 minus 9, which is the square root of, what's that? 16, which is 4. Ding, ding, ding. I knew that had to be 4. Okay. So what's the cosine of this angle here? Cosine of that angle is 4 over 5. Adjacent over hypotenuse. So the answer to this is 4 over 5. even though we're down here in this quadrant, remember cosine, all students take calculus, cosine is positive down here. So it's going to be 4 over 5. Adjacent side was plus 4. The hypotenuse is always positive 5. 4 over 5. No doubt about it, right? Now, got it? There, just like all the examples, there is a checkpoint afterwards. Please do the checkpoints. By the way, if you're looking at your book, you can see that same drawing we just basically did. Maybe theirs isn't quite as pretty as mine, but it's close. Okay, never mind. Okay? Let's do, anyone need this one any longer? Yay or nay? Everybody good? Erase? Okay. Let's do example 7. These are so much fun. Write an algebraic expression that is equivalent to each of these expressions. Okay? So here's the first expression. The sine of the arc sine, or arc cosine, of 3x. Now, they tell us that 0 has to be between less than or equal to x, and that's less than or equal to 1/3. Okay? Don't know if we'll need that or not, but we'll go with that. Okay? Now, we want an algebraic expression that is equivalent to that expression. Guess what? We're going to start it the same way we did before. Okay? What will that be? What does that represent? Inverse cosine of 3x. An angle. Want to name it theta like our favorite? Okay, we'll name it theta. Now we'll do what? Draw a picture. But this is 3x. Could we put that as 3x over 1? Okay, so then this is going to be a good old unit circle, isn't it? Okay, if I could draw a circle. Now, what is cosine? Wait, I'm sorry. Doing this kind of backwards. Let's write the equation for that. What's the equation? Y'all were doing so well at this. 3x equal cosine theta. I jumped ahead. So now we'll express this as 3x over 1. So your 3x, is, what is cosine always? Call another hen. Adjacent over hypotenuse. So your hypotenuse is 1. That's why I drew a circle of radius 1. And your 3x is going to be your x value. So let's just choose it to be here. Somewhere here, anywhere. Let's do this to be 3x right there. Can't be outside that. It has to be inside, right? Okay? And this is going to be 1. That's going to be your adjacent side. Okay? Now, what would sine then be? This is sine of theta, and this is your angle theta right here. Okay? So we want the sine of theta. And what's the sine of theta? What is sine? Opposite over hypotenuse. Opposite is the y side. So this is your opposite or your y. And what would that be? This is your x side, 3x. That's why I don't like calling it x, because it's now 3x. So the adjacent is 3x. The opposite, let's just go back and call it opposite. Let's call this adjacent. This is opposite. What would that be? So ugly. Okay. The opposite is what? We've just done it a time or two. Pythagorean theorem? What would that be? Square root of? Of what? 1 minus? Isn't that 3x squared? Which 3 squared would be 9x squared. Does that make sense? Okay? And then what's the sign? If that is your opposite side, the sign of this is opposite over 1, which is 1 minus 9x squared. Does that make sense? Now, let's see if this makes sense. If x is 0, that would be 1. If x is 1/3, well, 1/3 squared would be 1/9, and 1/9 times 9 would be 1. 1 minus 1 is 0. All those would work. That's why we had to choose the x between 0 and 1/3. If there's anything greater than 1/3, you have a negative number in your radical. We don't like that. Okay, how is our time going?
11:20.
Huh?
11:20.
11:20, and we go till 11:15. Hey, y'all are expecting a refund, aren't you? No. No, you have to pay me more, right? No, there's no extra charge. All right, we will have to finish 11. Where's my pen? Oh, someone borrowed my pencil, didn't they? I've got another one. Go ahead. Okay, I'm just kidding. Boy, you used all the eraser, didn't you? Okay. We're going to begin next time at 7B. And so let me put my marker in place. Homework exercises here. Do any of the odds 5 through 17. They're all at Calc Chat. 5's at Calc View. 19's at Calc Chat. Any of the odds 21 to 35 are all at Calc Chat. 21's at Calc View. 37's at Calc Chat. 39 to 43 all at Calc Chat. 39's at Calc View. 45 to 49 all at Calc Chat. 45's at Calc View. 51 to 61 all at Calc Chat. 55's at Calc View. 63 to 71 all at Calc Chat. 65's at Calc View. 73's at Calc Chat. 75 and 77 are at Calc Chat. 75's at Calc View. 79 through 83, they're all at Calc Chat. 83's at Calc View. 85 to 89, they're all at Calc Chat. 91's at Calc Chat. Any of the odds 93 to 97 are at Calc Chat. And then some of the applied problems 99 through 105, they're all at Calc Chat. True or false, 107 and 109 are at Calc Chat. Then you have some more exploration problems if you want to do them. Any of the odds, 111 or 113, both at Calc Chat. 115 through 119 are both at Calc Chat. 123 to 125 are all at Calc Chat. And 127 is at Calc Chat. You can think about doing 129. We'll pick up the rest of those next time and get started on 4.8. I don't know now that we'll finish 4.8 next time. We'll try. It's a short section. We might be able to do it. But we'll finish 4.7 and go on to 4.8. Good deal. See you Thursday.
I didn't turn in my quiz, or I didn't finish it because I've been working and my uncle has been sick. I've been working Tuesday and Thursday morning before class, and last week that's why I missed the whole week.
Right.
So I had to be in Montgomery to work for Johnny King for Dollar General to clean up because Dollar Tree basically bought Dollar General, and I had to basically inspect the inside the building, like clean around the building.
Right.
And I missed class, so I didn't take my test or turn in the quiz. Is it all right if I make it up?
Okay, sure. Do you have your test?
Not with me right now.
Yeah, I mean, but you got one.
Yes.
Oh, okay, right. And it's a test. It's not a quiz. It's a test. Okay.
Okay.
Right.
So
Yeah, just get it in as soon as you can.
Okay. Thank you.
And preferably before I give you the next one. So if you can get it in by Thursday, that'd be great.
Yes, sir.
But because of this, you can have it longer if you need it.
Thank you.
Okay. Yes, sir.
Are we going on a science trip?
Not today. I I have called, I've emailed, I emailed again and copied his wife on it because I know Kathy too. And usually that gets a response. I still didn't get a response. I checked this morning, no response. I called again this morning, left him another message. I can't make him respond. It gets this way sometimes, I guess. I don't know. They may be shorthanded. I don't know. Seems like for some reason this is the time of year when they tend to take vacations and stuff, which I would not.
Yeah, it's kind of odd.
Huh?
It's kind of odd
Yeah.
for them to take vacations.
Yeah. So anyway, maybe it's a quiet time of year and that's when they take off. I don't know.
Yeah.
But anyway, I can't get in touch with them, so I know it can't be today. I haven't had time to get the van or anything. So it's either going to be Thursday, Tuesday, or not at all. Yeah. So we'll see. I tried every way I can. I haven't called his home number because I'm in class he works late, so he sleeps in late, so I can't call first thing in the morning. And the window to catch him is usually between, say, about 10 and 2, but I'm always in class between 10 and 2, so I can't catch him at home either. So I'll try to catch him again. If I haven't heard from him today, I'll try to call again this evening.
Okay. I have a question.
Yeah.
Physical science 2, do we take field trips? Or is that...
No, there's no field trips in that. It's just working problems.
I got you.
Yeah.